let's take it up a notch. And you might read this, you're like, how is this any different than what we were working? Well, let's just take it word by word. So how many molecules? So over here I'm going to put molecules. Molecules is 3.21 grams of C4H10. Well, the reason it's a little bit different is notice that we don't want moles, we want molecules. So we can get to, if we can get to moles, okay, then, if we can get to moles, then we can get to molecules. So just to kind of remind you how this works, what is the relationship between moles and molecules? 1 mole is equal to 6.022 times 10 to the 23rd molecules. Very good. So how are we going to get from grams to moles? So we are going to get from grams to moles using the molar mass. So that's why this problem is a little bit different. For those of you who keep wanting to use Avogadro's number, remember if you're dealing with atoms, you use Avogadro's number, counted atoms, and if you're dealing with counted number of molecules, you'll also use Avogadro's number. So let's see what this looks like. Again, before we can do that first step to go from grams to moles, the molar mass step, we actually have to calculate the molar mass. And here's a good time to tell you, I hope everybody is listening because I don't want to count off any points on your test, but you always have to show coming up with this molar mass, okay? I know it's just like a simple kind of problem to put into your calculator, but you have to show your work here. So for carbon, the decimal number for carbon is 12.01, and there are 4 of them. The decimal number for hydrogen is 1.08, and there are 10 of them. So that's how this came about. So rounding to 2 decimals, we get 58.12, and then units of molar mass are grams per mole. Again, I probably would write it like this, 58.12 grams per, or in 1 mole. And then I would use it like that or flip it as I needed to. So here we go. Let's work this problem. What's the first term going to be? The first term is going to be the thing we want to convert, which is that mass of C4H10. 3.21 grams of C4H10 was given in the original problem. According to the strategy, what is the next term? Next term is going to be the molar mass, and what's it going to look like? Molar mass is going to look like this, so grams will cancel, we'll be left with units of moles. This is what I call the flipped version of the molar mass of C4H10. Alright, very good. So we need one more term. Our grams have canceled, we're left with units of moles here, and now we need moles to cancel, be left with molecules. So what does that last term look like? Yep. It looks like this, with Avogadro's number on top, 6.022 times 10 to the 23rd on top. That would be molecules, 6.022 times 10 to the 23rd molecules, and 1 mole on the bottom. And I know this kind of wrapped around, so I ran out of room on my slide. Hope this works for you. So this actually would go up here. So in this case, moles cancel, and we're left with molecules, which is exactly what we want to be left with. Now we need to round this thing. Is there any uncertainty right here? Yes. Is there any uncertainty right here? Yes. Is there any uncertainty of Avogadro's number? Yes. So how many sig figs do we need to round our answer to? I got 3 sig figs. So rounding to 3 sig figs, is it going to be a big number? Yes, it's going to be a big number. Never hurts to kind of look ahead at what you think the answer is going to be. And my answer key's wrong. Hold that thought. There we go. A big number it is. I get 3.33 times 10 raised to the 22nd power. 3.33 times 10 to the 22nd molecules is what this mass of this compound is.